Let's do this question. When 3 dice are thrown simultaneously, what is the probability that the sum of the 3 numbers is equal to 11? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. For this, you can refer the section on grouping in permutation and combination. Alright, let's move on. We know that probability is favorable events by total events. Now, over here we have 3 dice. Let me call them as A, B and C, and we need to get the sum equal to 11. That is A plus B plus C is equal to 11. Now, because we are throwing dice, each of these values has to be greater than or equal to 1 and less than or equal to 6, right? Because 1 is the least and 6 is the maximum value that any dice can get. Alright, now let's start with the lower limit over here. Let me give 1 to A, B and C. So after distributing 1 to each of these 3, I consume 3 items. So 11 minus 3 is equal to 8. I'm left with 8 items. Now do remember, if you are not getting this part, refer the section of grouping under permutation and combination so that you will be able to follow this. So this is an application of permutation and combination in a probability question. Alright, let's move on. Over here, I have 8 more items, right? And these 8 items can be given to 2 people. So I have 8 dots and I have 2 lines, right? Because if I have 2 lines, I divide these 8 dots into 3 sets. So that's a total of 11 items, of which 8 are of one type and 2 are of one type. So this can be distributed in 10 factorial by 8 factorial into 2 factorial ways, which is equal to 10C2. Now, over here, we have an upper limit also. So to find the answer, we need to find 10C2 minus the violations, right? So we need to do 10C2 minus the violations. What are the violations? The violations are obtained when any value gets a value greater than 6. Alright, now let me call these 3 as A, B and C. That is the values after giving 1 to each of them. Now we know that A plus B plus C has to be equal to 8, right? And A, B and C has to be less than or equal to 5 because each of these has already got 1, right? A, B and C has to be less than or equal to 6. If you subtract 1 from capital A, you get small a. If you subtract 1 from capital B, you get small b. If you subtract 1 from capital C, you get small c. Now, because we have already distributed 1 to each. Now, to satisfy this condition over here, A, B and C in small letters has to be less than or equal to 5. Alright. Now, let's find the violations. To find a violation, let me allocate 6 to this A over here. And I am left with 8 minus 6, that is 2 items. And I have 2 dots and 2 lines, right? Because I have to divide it between 3 people. So 2 dots and 2 lines, that's a total of 4 items. 2 are of one type and 2 are of one type. So this can be distributed in 4 factorial by 2 factorial into 2 factorial ways, which is equal to 4C2, right? Now, therefore, the violations are 4C2 into 3, right? Because the same 6 could have been given to B and to C. So, the answer is 10C2 minus 4C2 into 3, which gives you the answer as 27. And that is your answer in terms of the ways in which this can be done. So, the favorable ways is 27. Let's also see this just for our understanding how these 27 distributions would be, right? Now, if you have 3 dice A, B and C, these are all the possible ways in which you can get a sum of 11, right? Let me keep 1 over here and I need 5 and 5. Or I keep 1 over here and I can get 6 and 4. The total is 11, right? And let me keep 2 over here and I would need 9 more points, that's 6 plus 3, or 2 over here and 5 plus 4. That also gives me 11. I can have 3 over here and 6 and 2, 3 over here, 5 and 3, 3 over here and 4 and 4, right? Now 3, 6, 2 is a repetition of what we have over here. So we strike this out. Similarly, with 4 over here, I can have 4, 6, 1, 4, 5, 2 and 4, 4, 3. These are repetitions because 4, 6, 1 is already available over here, right? 4, 5, 2 is already available over here and 443 is available over here, right? Because we are trying to do the various arrangements of each of these, right? Similarly, 551, 542, 533, 641, 632. These are all the ways, and these are already covered in the previous arrangements. Now let's see one by one. 155 can be arranged in three ways, right? I could have 155, I can have 515, and I can have 1551. So these are the three ways, which I have written 3 over here. Now similarly, 164, I can have it in 3 factorial ways, because it's 3 different items in 3 places. They can be arranged in 3 factorial ways. That's the 6 over here. What about 263? You have 3 different items in 3 places. It can be done in 3 factorial ways, which is equal to 6. What about 254? Again, that's 6, because it's 3 items in 3 places. 353. This can be arranged in 3 factorial by 2 factorial ways, which is equal to 3. And 344 can also be arranged in 3 factorial by 2 factorial ways, which is also equal to 3. Now if you add all of these, you get 3 plus 6 is 9, 9 plus 6 is 15, 15 plus 6 is 21, 21 plus 3 is 24, 24 plus 3 is 27. That's the 27 which we obtained over here. So following this method, we do it much faster and we avoid making careless mistakes. Alright, let's move ahead with the question and find the probability. The question says we need to find the probability such that the sum is equal to 11. We have found that there are 27 cases in which the sum will be 11. Now probability is favorable by total. So favorable is 27. And what is the total? The total is 6 into 6 into 6, right? Because we are throwing 3 dice. Each dice can have 6 possible outcomes. Therefore, dice 1 and dice 2 and dice 3 can have 6 into 6 into 6 possibilities. Therefore, your answer to this question is 27 divided by 6 into 6 into 6.